So let's talk about arithmetic mean and what that means. So arithmetic mean is something that we like to call a measure of central tendency. A measure of central tendency. Okay? What that really means is it helps us to look at a set of data. So if we have a set of data points of numbers, etc., it helps us to find kind of the center of those data points. Where is another word we associate with this is where is the average, or where might the average point be? Okay, so the arithmetic mean kind of helps us to do that. It's the most common form of measures of central tendency. It's the first one that we kind of learn about. So it's kind of where we start. So to give us an example here, we're going to use a formula. So I'm just going to go to the next page here. The formula that we use for mean, we have mean equals the sum of all terms. What that means is it's adding up all of the terms, so all of the numbers that you have in a set, divided by the number of terms. Right, so this is how many terms you have, how many numbers are in the set, so you just count them all up. So for example, let's say that we had a set that was 10 soccer games. Okay, so we have 10 games, and we just wanted to record our scores in that game. So let's see how many goals we got here. So let's say we had 7 in the first game, 2 in the second, and so on, 4, 7, maybe we got 0 one game, 1, 3, 2, 6, 1. What numbers these are don't matter a lot in how we deal with them. It's just we need 10 numbers. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to match up with our 10 games. Okay, so to find our mean, we have to, on the top, find the sum of all terms. So that's adding all of these up. So we take 7 plus 2 plus 4 plus 7 plus 0. We know that won't matter, but we're going to put that in anyway. Then we do plus 1, plus 3, plus 2, plus 6, and finally plus 1. So 10 numbers all added together. And then divided by the number of terms. So how many numbers do we have? We know there are 10 games, but if we didn't know there were 10 games, we could just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that there are 10 terms. Okay, so now we just add up all of these numbers in our numerator. That'll give us 33. Okay, so now we have 33 over 10. So if we do that division, our mean becomes 3.3. And now we see a little bit about why we call it a measure of central tendency, because if I were to ask you, what is a number that would fit very well into this data set kind of right in the middle, 3.3 would actually be a pretty good number there. It would be kind of in your average range in the mean. Okay, so that's the first way that we use means, is to take a set of data and find the mean. But there is one other way that we can use it, and that is to kind of work backwards. Okay, so let's take an example here. So this example is all about football. In one game, a football team has offensive drives of 45 yards, 43 yards, 24 yards, 21 yards, 44 yards. The coach wants the team to achieve a mean of 35 yards per drive for this game. So the question is, what must the length of the next offensive drive be if the team wants to meet this goal? So instead of starting with a complete data set, we have an incomplete data set. Right? We have all of these drives. So we have, I'm just going to write them down over here so I can use them. So we've got 45 yards, 43 yards, 24 yards, 21 yards, and 44 yards. But we also have some other drive, some drive that we haven't determined yet, which we're going to call X. Okay, so this is still our data set here. So we can still use that formula, mean equals the sum. I'm just going to use this sigma symbol. It just means add up everything. So the sum of all terms over the number of terms. Right, that's just shorthand. Okay, so we can still do this math. So we can still do, well, we have to add all these up, but we don't know what x is. So we can add up everything else. So if we do 45 plus 43 plus 24 plus 21 plus 44, we will end up with 177. Okay, it's just some quick math. But we still have that x left over, and we still have to add it on. So we're going to do plus x, and we'll worry about it in just a moment. Okay, so we've got 177 plus x over the number of terms. We know that there are 1, 2, 3, 4, 5, and then our extra term, 6. So 6 terms in total. So our mean should be 177 plus x divided by 6 will equal our desired mean of 35. We can write that again, write it below just to make it a little bit easier for us here. So 35 yards will equal 177 plus x over 6. So if we want to find that x, so I had this in red, I'm going to keep it in red here just for my sake. So if we want to find that x, we have to do some algebra. We have to get x on its own here. So to do that, we start as far away from the x as possible. We start with this division. We're going to get rid of that denominator, make it a little bit easier for us here. I'm going to use blue just to show that we're taking steps here. So to get rid of this denominator, this divided by 6, we must do the opposite. The opposite of division is multiplication. So we're going to times by the thing we want to get rid of. So we're going to times by that 6, because times 6 and divided by 6, they cancel out. They make 1, so we don't care about it no more. But then whatever we do to this side, we must do to this side. So we now have 35 times 6. 35 times 6 gives us 210 equals 177. And then, of course, that's plus x. So now we just need to get rid of that 177. It's plus, it's a positive. So we must do the opposite of that positive to get rid of it. So we do negative or minus 177. 177 minus 177 is, of course, 0. So we can cancel those out. And then whatever we do to this side, we must do to this side. So minus 177 will give us our final answer here of 33 yards equals x, or x equals 33 yards. So there's your answer. So if the coach wanted a mean drive length of 35 yards, then the next one must be 33 yards. So there's two ways that we use arithmetic mean, either starting with a complete data set to find the mean, or starting with an incomplete data set and the mean to complete the data set. All with the same formula, just working forwards or backwards.